Welcome to my projectbazaar.com.
Now we discuss about the product for a novel VLSI DHT algorithm for a highly modular and parallel architecture. Then we discuss the abstract for the product. A discrete Fourier transform is used to many digital signal processing applications, as in the signal and image compression technique, filter bank signal representation and harmonic analysis. A discrete Hartley transform can be used to efficiently replace the DFT when the input sequence is real. In this literature, there are some fast algorithms for the computation of DHT and some algorithm for the computation of generalized DHT. There are two several split radix algorithms for computing the DHT with the low arithmetic cost. The classical split radix algorithm is difficult to implement the VLSI due to the irregular computational structure and due to the fact that the butterfly is significantly different from stage to stage. Thus, the necessary to derive the such new algorithm that is suited for parallel VLSI system. There are also the literature several fast algorithms, thus the recursive strategy. Since the DHT is a computational intensive, it is necessary to derive the dedicated hardware implementation using the VLSI technology. One category of VLSI implementation is represented by systolic array. There are many systolic array implementations for DHT. Systolic array architecture are modular and regular, but they use particular biplaning and not parallel processing to obtain the high speed processing. For DHT architecture, a new VLSI very large scale integration algorithm for a 2 power n length discrete Hartley transform that can be efficiently implemented on a highly modulated and parallel VLSI architecture having a regular structure is presented. The DHT algorithm can be effectively split the several parallel parts that can be executed concurrently. Moreover, the proposed algorithm is well suited for the sub-expression sharing technique that can be used to significantly reduce the hardware complexity of highly parallel VLSI implementation using the advantage of proposed algorithm and the fact that we can efficiently share the multiplier with the same constant. The number of multiplier has been significantly reduced such that the number of multiplier is very small comparing with that in the existing algorithms. Moreover, these multiplier with the constant can be effectively implemented in VLSI architecture. Next, we see the flow diagram for the product. First, the input binary bits to apply the first stage adder section. This is the adder section for 8-bit addition work for using the CSA based logic, and the CSA based logic to apply the carry save adder architecture for addition and subtraction process. This process to reduce the hardware complexity and to increase the processing time compared to existing methodology. This is our carry propagation time minimization process for overall input addition architecture. Then to apply the multiplying function. This multiplying architecture mainly used to CS the carry select order for addition process and to apply the CPL logic for partial product generation unit. This CPL logic multiplier architecture to reduce the hardware complexity for overall DHT process. The DHT process mainly consider the addition, subtraction and multiplying process for overall architecture work to implement the 8-bit limitation for overall functions and to apply the processing result and 16-bit output results for multiplying results for our the processing architecture. This is our the overall DHT process. First, the input bits are applied to in addition, and the addition and subtraction mainly parallel process for first stage and second stage process. First stage process to split the half of functions and the first half function to perform the addition work and the second half function to perform the subtraction result. These results to apply the multiplying function. These multiplying function results to multiply the 8-bit addition results. This addition result and to apply the multiplier result. The multiplicand and multiplier function to perform the multiplier operation and to produce the 16-bit output result for final transform results. And to calculate the simulation synthesis result for overall architecture. The simulation and synthesis process for mainly applied for processing result.
Next we see the final output for the product. The DHT process for run by Xilinx IC project. Just we open the DHT Xilinx IC project file. This project was developed in VHT language and to using the structural modeling process in our VHTL process. Our DHT process was 8-bit DHT algorithm for overall DHT transform architecture. Then to select the simulation process and to run the simulate behavior model. This behavior model to create the Xilinx ISIM projects. This ISIM project mainly used to run the simulation result for DHT transform architecture. This ISM project navigator to apply the binary input for our overall architecture. The binary input to apply the or any type of result. The input to apply the any type of 8-bit input for 16-bit processing result. Then to apply the 16-bit input and to process the output result for final output result for 16-bit DHT transform result. This is our simulation process for overall architecture results. Then to close the simulation result and to calculate the implementation process. This implementation process to run the RTL schematic process for overall architecture. This is our RTL diagram for overall processing representation. This is our the RTL diagram for DHT transform. This RTL represents the what are the logical paths present in overall architecture result. And to calculate the technological schematic. This technological schematic is mainly used to what are the technological. This technological means what are the lookup tables, input output functions, processing results are placed in our overall architecture. This is our architecture results for technological diagram, and this is our technological diagram. This diagram to represent the input outputs and lookup table wire connections pass overall architecture. Then calculate the synthesis report. This synthesis report is mainly used to device what are the device utilization in our overall architecture result. This is our device utilization of DHT transform result. And to calculate the timing summary result for overall architecture. This is our timing summary for processing the DHT transform architecture. This is the delay time for overall processing running time. This is our the lookup table function for overall area of DHT transform architecture. This is our simulation implementation result for overall architecture.